Yes, welcome to the video. In this video, I am going to discuss the concepts maximum and minimum values of functions of two variables. So this is very important concept in view of all university examinations. Okay, usually for 2 marks or for 8 to 10 marks, they may ask any problem related to finding maximum and minimum values for the given function. Okay, so this is a very much interesting concept in a function of several variable. Okay, here our task is to find maxima and corresponding maximum values, minima or corresponding minimum values. Okay, so let us understand uh, this maxima and minima, so that directly I am going with the conditions, nothing but working rule. Okay, working rule to find the maximum or minimum values of the given function xy. Okay, so just go with the steps. Step 1, find dou f by dou x and dou f by dou y and equate it to 0. For the given function, you are differentiating one time with respect to x and one time with respect to y. Then you equate it to 0. If you equate it to 0, obviously you are getting two equations. Okay, solve these two equations, then you are getting few points. Okay, like a1 b1, a2 b2, like that you are getting some pair of values. Okay, then step 2, in step 2 you are finding second order derivatives, but here we are giving some specific notation. Dou square f by dou x square is represented by L, dou square f by dou x into dou y by m, and dou square f by dou y square by n. So L, m, n. So you are finding L, m, n second derivatives. Okay, then step 3. So in step 2 you are getting LMN values. On the basis of this, in step 3 you are having 4 important key points to understand maxima and minima. Okay, so what are the 4 points, 4 key points? Let us see one by one. If ln minus m square is greater than 0, you are multiplying L into n. Okay, and subtract m square from ln. So ln minus m square is positive, then L is, if L is negative, then if you get this ln minus m square is positive, then go with L value. If L value is negative, so here ln minus m square is positive, L is negative, plus and minus. In this case, the points a1 b1 is a point of maximum. A1 and b1 are the points of maximum. Okay, or you can call it as maxima, and the corresponding functional values f of a1 comma b1 is the maximum value. Second, if ln minus m square is positive, that is greater than 0, and if L value is greater than 0. In first case, ln minus m square is positive, L is negative. In second case, ln minus m square is positive, L is also positive, means plus and plus. In this case, the points A and B, A1 and B1 are the point of minimum or minima, and corresponding functional values f of a1 and b1 is a minimum value. Okay, so this is the first one, is the condition for maxima and maximum value. Second is condition for minima and minimum value, and the third one, if ln minus m square is negative. So in first two cases ln minus m square is positive, but third case is telling when ln minus m square is negative at a1 b1, then f of a1 b1 is not an extreme value, that is there is neither a maximum nor a minimum at a1 b1. In this case, a1 and b1 is a saddle point. Okay, so means you can conclude from third point, if ln minus m square value is negative, then it is there is neither a maximum value nor a minimum value for the points a1 b1. Fourth point, if ln minus m square value is equals to 0 at a1 b1, then no conclusion can be drawn about maximum or minimum. So no need of further, sorry, it needs a further investigation. Okay, so this is the working rule. So you just see once. First step is to find first derivative values dou f by dou x and dou f by dou y equated to 0. You are getting two equations, solve each other and get point, that is values of a1 b1 a2 b2 so on. Then in step 2 you are finding lmn. So l is lmn are the second derivative. Okay, second derivatives values you find it. Okay, then find the value of lmn. Then on the basis of lmn, so you are calculating step 3. If ln minus m square is positive, l is negative, then the point a1 b1 are said to be maxima and having corresponding maximum value. If ln minus m square is positive and l is also positive, then a1 b1 are said to be minima and having corresponding minimum value. If ln minus m square is negative, then neither a maximum or nor a minimum for the given points. Then last one, if ln minus m square equals to 0, then no conclusion can be drawn about maximum or minimum, and you can write it needs further investigation. Okay, then on the basis of this working rule, let us understand well how to find maximum and minimum. Okay, first problem, discuss the maxima or minima for x cube plus y cube minus 3xy. So x cube plus y cube minus 3xy is the given function. Let us consider this as equation 1. So you take it as f of xy equals to x cube plus y cube minus 3xy, given function. So our first step is to differentiate the given function with respect to x and y. So therefore dou f by dou x value is 0, dou f by dou y value is 0, means you are equating to 0 the derivatives, right? So differentiation of given function, x cube differentiation gives 3x square and y cube differentiation 0, and minus 3xy differentiation gives minus 3y. 3x square minus 3y you are equating to 0 and you take it as equation 2. Similarly, your dou f by dou y gives 3y square minus 3x equals to 0, equation 3. Okay, then your task is to solve equation 2 and 3 to get some x and y values. Usually you see here equation 2 is 3x square minus 3y, equation 3 is 3y square minus 3x. Both the expressions are looking same. Suppose in case while solving any of the problems, if comparing to these two expressions, if any of the expression is looking complex, then you choose easier expression for solving. Okay, suppose here equation 2 and equation 3 are looking same. Okay, suppose in some of the examples equation 2 is looking somewhat complex, equation 3 is looking simple. You solve equation 3 first, you get some points either for x or y, then using x and y value you find, means you solve equation 2. So that is the obvious procedure. Okay, here both are looking same, then you take the first expression. So from equation 2, if you take 3 common, you are getting x square minus y equals to 0. Then if you solve this, your x square equals to y. Okay, that means y value is x square. This y value you substitute in equation 3. Then y square, in place of y square you can write x power 4, that is 3 into x power 4 minus x equals to 0. Then if you solve this, you are getting x value 0 and x value 1. Okay, then here it is very important point. Here when you are solving equation 3, you are getting two x values. first x value is 0, second x value is 1. Then you need to find corresponding y values. That means to find y values you can use equation 2 or equation 3, that is your choice. But here when you are using x equals to 0, you need to find corresponding y value. Otherwise, suppose you are using x value 1, x value 1 means you find corresponding y value. Okay, then here if you solve when x is equals to 0, if you use this, your y value is 0. Then if you use x value 1, then corresponding y value is 1. Then your points, critical points are x comma y, means 0 comma 0 is the first critical point. Then when x equals to 1, corresponding y value is 1. Therefore 1 comma 1 is one more critical points. Okay, so after solving the equations, whatever the points you are getting, the points are known as critical points. Okay, then here you are getting two sets of point. First set is 0 comma 0, second set is 1 comma 1. So always in the set the first number is related to x, second number is related to y. Okay, next you go for step 2. In step 2 we are finding LMN. LMN means second derivative values. So you already got dou f by dou x value. Go for dou square f by dou x square. Okay, so 3x square minus 3y, this one if you differentiate one time with respect to x, you are getting 6x. Similarly equation 3, if you differentiate with respect to y, you are getting 6y. Therefore your L value is 6x, N value is 6y. And what about M? M is dou square f by dou x into dou y. You already got dou f by dou y value. So dou f by dou y value is 3y square minus 3x. This term you differentiate with respect to x. Therefore first term is 0, you are getting minus 3. Therefore your M value is minus 3. L value 6x, M value minus 3, N value 6y. Then go to the points. So you got here in this case two sets of points. You go to the first set of point. First set of critical points 0 comma 0. It means x value 0, y value 0. So you substitute x value 0, y value 0 in expression L. L is 6x. In place of x, if you substitute 0, then your L is 0. M is containing constant minus 3, you write as it is. N is 6y. So here y value is also 0. Therefore N value is 0. L value 0, M value minus 3, N value 0. So then you go for calculation of ln minus m square. So ln minus m square means L value 0 minus of m square means minus 3 whole square. If you solve this, your answer is minus 9. So therefore ln minus m square is negative. Okay, then you remember 4 cases. Well, ln minus m square is negative, then you need to check, okay, you no need to check L value, right? So when it is negative, then f of 0 comma 0 is not an extreme value, hence there is neither a maximum nor a minimum at 0 comma 0. Means you got here third condition, right? Because you got ln minus m square value negative. Then go with the second set of points 1 comma 1. At point 1 comma 1 means x value 1, y value 1. So you got expression for lmn. There you use x value 1, y value 1. Therefore your L value is 6, m value minus 3, n value 6. Here you calculate ln minus m square. So ln minus m square, if you calculate, the answer is 27. 27 means it is greater than 0. When ln minus m square is greater than 0, then you need to check L value. So L value is 6. 6 means it is also positive. Ln minus m square is positive and L is also positive. Then it is satisfying second case, that is it is having a minima. Then the points 1 comma 1 is said to be minima and corresponding values are said to be minimum value. So the points 1 comma 1 is known as minima. So this x value 1, y value 1 you substitute in the given function. Okay, then your functional value is minus 1. Here minima is 1 comma 1 and the minimum value is minus 1. Okay, so in next class I'll explain one more example related to maxima and minima. Thank you.